Hey everybody, this is Larry. There's 30 seconds left. This is Leetcode Weekly Contest 197. Yeah. Hit the like button, hit the subscribe button, join the Discord. Let me know what you think. What was your favorite poem? Which poem did you hate? Yeah, wish me luck. I know I've been saying this the last couple of live casts, which is sad because that means that it's still true. Is that I haven't been doing so well lately, so I need all the good luck I can get. So give me that good luck and let's go in 3 seconds.
Yeah,
2,
go.
1.
Very,
Cool.
yeah.
Let's go. Q1, number of good pairs. So the thing about this one was, I mean, I did it pretty quickly. I did it in 56 seconds, it seems like. And, well, it is just you just do 2 for loops, and then as long as they're not, I mean, you just do 2 for loops and make sure that the index is on together, and also making sure that you go one way. And that's pretty much all you have to do. It's a little bit, I feel like while I was doing it, I was a little bit rushed, or a lot rushed. And there are people who did it in 29 seconds. So, so definitely very impressive. Like I'm typing as fast as I can. Maybe I could have used a little bit better. But that said, you know, I'm not going to try to save 5 seconds by not running tests and checking it, because that might cost you 5 minutes, and for me, it's not really worth it. The number of substrings of only once. So this one, initially, I thought that I was going to use some kind of sliding window, to be honest. But someone did this in 30 seconds. Oh man. But yeah, I really thought that it was going to be some sort of sliding window. But I didn't really. And then as soon as I kind of thought about it more, as I was typing it out, I thought, hey, actually, because you cannot replace or there's nothing like that, all you need is just the count how many contiguous ones there are. And actually, to be honest, I implemented this in a little bit weird way. I think you could just use some sort of one length encoding, and that would have been good enough, to be honest. But because I was in the mindset of sliding windows, my implementation kind of reflected that, and my code kind of looks like that. And yeah, that's pretty much how I did this one, basically. And the idea is that for every length you take, it adds another n, giving it, like, you know, 1 plus 2 plus 3 plus 4 and so forth. So that's kind of how I keep track of it. And yeah, and I had an off by 1 just for a little bit because I wasn't sure how to do it, or like I wasn't sure about the math on the off by 1s. But as soon as I fixed it, it was okay, and I still got it in about 2 minutes, which I thought was fast, but a lot of people got it even faster. So
oh no.
yeah, I mean, it's one of those days. Cool. Like, what is wrong? I'm like, all right, I don't need this plus 1, and also I need to start at -1 so that it counts right. But if I just did one length encoding, this would have been much clearer, so I can understand how people got it so quickly. And then path with maximum probability. I was so the short answer for this problem is that it is greedy slash Dijkstra's algorithm. I mean, Dijkstra's algorithm requires it. You know, it is a greedy algorithm, right? But for me, I had to convince myself, and that's what I was thinking in the beginning. I had to convince myself that, I mean, clearly it's the shortest path problem of some sort, but the implementation and whether we could do greedy Dijkstra wasn't so super clear to me. Also, the input was a little bit weird in that I don't know why they separated out the edges and the success probability and not putting them together. Maybe they try to not make it a hint or something, but I also did have some concerns about just in terms of possible mistakes and stuff like that. So I was definitely trying to be mindful, but for this one, I think right now I'm just trying to convince myself that the greedy algorithm is okay, because I was like intuition wise, that's what I thought, but I really wasn't sure. So yeah, so that's basically what I was doing, and I was like, okay, if I'm going to do Dijkstra, the base case will be 0, so that's what I put there. Yeah, and I was thinking whether like I think I was just thinking about data structure for a second of like whether I need to convert it, and I end up converting it to an adjacency list with the success probability as the edge. And yeah, and then I was just like, okay, let's just do a Dijkstra. Let's put a heap, and do. Yeah, we start by and this may look a little bit odd, but in Python the heaps are min heaps, so that's why I take the negative value, so that but what I do is that the base case is that the starting node has a 100% probability of starting, so I put in a 1 there. Yeah, now I get the probability and the node. This is right now standard Dijkstra. I think I was a little bit slow, but I was still thinking through what everything meant. And this is where if you had practiced it, and I did practice it to be honest, but you practice it enough, then maybe you'll be able to type it faster. But I was just, I don't know. I think I was pretty fast for these first 3 problems. Yeah, and this is again still standard Dijkstra. But instead of using adding as the rate, I did the probability times the rate of the success probability. I mean, I called it the rate, but yeah, that's pretty much it. And then I just have to add one more if statement for the end node, and then that's pretty much it. I have to unpack correctly for my for loops. I think that's mostly it. Maybe I don't remember. Let's see. Yeah, it looks okay. It looks to match the example, so I submit it. Wasn't 100% sure on that one, but yeah, that looks good. Feels good. Best position for service center. So this one I actually have some trouble with. I remember some. So this is just what experience buys you a little bit, and I don't know that I would get it any other way. The top person, Xiao Wu, did it in about 3 minutes, so a really experienced person would get it even quicker. But for me, and I'm gonna skip forward a little bit, but I just want to say because I just thought about this problem and I was doing things on paper for a little bit, but the sort of idea is that I was a little bit aware of the solution because I have done similar things before for computational geometry E thing. I knew 2 things. One is that it's called the geometric median, so it's a very standard thing. Well, not very standard, but I also knew that there was no easy algorithm. Or well, I would say that there's no it's not an easy answer. The reason why this worked a little bit and was because that when you look at the bounds, it's only within 100 times 100 bounding box, so that the position doesn't have to. It's not that much of a worry, but it's still like to be frank, a very crappy question for an interview, and maybe even for this kind of contest because, well, it's not really reflect reality at all. But yeah. So I'm gonna skip ahead real quick. There'll be a link below so that you could follow along, but because I literally don't do much, like I was, because I'm doing here is that I'm either playing around paper trying to draw some stuff, trying to see if there's any like weird dynamic programming that I missed, or but I knew that that wasn't the case, or I figured out that it wasn't the case because I was like, no, you cannot, or for me I couldn't figure out any way to pull out like linear components or whatever it's called, meaning that I couldn't figure out like a way to symbolize it because they all depend on each other in a way. So then I was trying to, and then I spent some time looking over my, because I've written similar code for this before, so I was trying to find similar code for that before. I'm not going to explain it live. I'll do it in the explanation portion, but I did have code written for this. That's how I was trying to. I spent a bit of time actually looking for my old code bases because I didn't. Younger Larry didn't categorize stuff or didn't have keywords that he could search. So, but now he could. Maybe I need to do a better job on that, but that's another story. But yeah, I'm gonna skip ahead. So stay tuned. I don't know how to solve this. Don't know enough math for this one. We have no idea. People have gotten it. But all the smart people have gotten it. Welcome back. But yeah, but basically I wrote up the template for, because I knew that I was going to need it, because I knew it was some sort of search algorithm. So this part I mean, and it should be straightforward, which is that given a center, x and y, that's how you, given a center x and y, that's how you calculate the total distance, right? The total cost function that you're trying to get. But yeah, now I gave up, or I took a quick look and be like, yeah, right now I'm just doing the really basic thing of playing around with the geometric median. And here I just literally take the arithmetic average to find the center, and then calculate that, and then just playing around with it a little bit. And I was like, okay, that's not that close. I mean, I knew that wasn't that close, I guess, but still. Yeah. But yeah, and then after that, I was like, okay, let's test all the points. I mean, I think I found my original code, but I was trying to just really understand how it works again. And it's hard to try to relearn what you used to remember from so I wrote this code maybe like a decade ago. So it took a long time to find it, and it took me like, I was like, and it's not plug and play, right? Well, also I wrote in C++ because it was 10 years ago, but it's not plug and play, right? So like I was like, do I really believe Past Larry? what has Past Larry done, you know? I don't know if he, I wasn't sure, to be frank. I think that's the kind of thing. And I was just playing around with the results in that regards. But yeah, I kind of so the way that I try to think about this is some sort of simulated annealing. Not quite though. to be frank. I mean, I think that's just the way that my mental model is. So definitely to be pedantic. Yeah, pedantically it's not simulated and outing, but it's just how I thought about it. And then I was like, oh wait, I need to get the updated thing. Yeah. And so I took 1,000 because I don't know, it's just a random number to be honest, but it just, I figured that so it, to me, what I was thinking at the time was that it was kind of like binary search thing, and that after a certain number of loops, we should be able to converge. But to be frank, I don't have proof for this one. Yeah. And I was like, okay, what am I doing here? Just double checking my code, because so what I do when I am doing new things is that especially now, I'm trying to be a little bit more careful. And one thing that I'm happy about for this contest is that I didn't get any wrong answers, because recently that's been plaguing me. But yeah, I mean, I don't have any proof on how this one converge. My thing on 1,000 is kind of similar to binary search, where after a certain number of iteration, it doesn't really matter, right? So yeah, I think that's pretty much. I mean, I was verifying that it was correct, but after I did, I submitted and it was good. I did okay. I didn't know this algorithm, so I had to learn it by Googling it. I'm sure a lot of people had known this one, so yeah. But it's good to kind of finally have, you know, it's good to finally have a contest where I finish in the top 100. Yeah. Which is, you know, maybe it sounds like a brag, but it's been a while, so you know. Yeah, I wonder if I could have done this. Wow, 4 minutes. Jeez, people are fast. People are fast. People are fast. Okay. Yeah, I'm going to record the explanations now. Yeah, thanks for watching. And I'll do explanations in different videos and stuff like that. Let me know what you think about this format. I'm still playing around with it. Thanks. I'll see you in a bit. Bye-bye.